Welcome to the debate. This discussion is brought to you by Ancient Archive Blueprints from the series Decoding the Pillars of History. This episode is called The Divine Code, Pythagoras and the Geometry of Reality, a Debate for the Ages. And right now there is a very good chance you are holding a smartphone, or, maybe you're sitting in a building held up by steel girders.
Which obviously we all take for granted.
Right, exactly. It feels like this ultimate triumph of cold, hard, secular logic. But what if it's actually a religious artifact? Like, what if the software engineers and the architects who built our modern world are essentially unknowingly practicing a 2,500-year-old mystery cult?
I mean, it is a phenomenal image. I will give you that. The idea of a Silicon Valley coder as some sort of secret mystic. But I would argue that modern mathematics is defined entirely by its successful break from that exact mysticism. We stripped away the superstition to build a purely rational, objective enterprise.
And that is the exact tension we're diving into today. Because, I argue that modern mathematical rationalism is a direct, albeit secularized, continuation of Pythagorean mysticism, driven by the exact same fundamental faith that numbers are the foundational source code of reality.
And I argue that modern mathematics is purely logical and defined by its explicit break from Pythagorean mysticism, specifically, through our embrace of irrationality and rigorous proof over cultic dogma.
So to really get to the bottom of this, we have to transport ourselves back about 2,500 years. If we look at Pythagoras, born on the Greek island of Samos around, I think it's 570 BCE, we aren't just looking at a mathematician in the modern sense.
Definitely not.
Now, after absorbing the astronomical and mathematical secrets of the Egyptians and the Babylonians, he settled in Croton and he founded a secret society, the Pythagorean Brotherhood. And he didn't just teach geometry, right? He founded a religion based on one radical, world-shattering premise, which was all is number.
Right, but we really need to emphasize how radical that was for the time.
Oh, exactly. You have to remember the context here. Before Pythagoras, the human experience was largely viewed as, terrifyingly chaotic. The world was subject to the unpredictable whims of gods who sent storms or plagues or bountiful harvests.
Just based on whether they were angry or happy that day.
Precisely. But the Pythagoreans proposed this revolutionary shift. They argued the universe isn't chaotic at all. It is a deeply rational, orderly structure built entirely on numerical relationships. And here is the big aha moment, I think. Human beings couldn't invent right angles if the universe didn't explicitly permit them through its own mathematical source code.
Right.
So, to the Brotherhood, understanding math was literally reading the mind of the divine. And my position is that this exact philosophy is the unseen engine of our world today. Every time a software developer writes code, they are operating on the absolute faith that the universe obeys this invisible numerical grid. We are in essence still practicing the ancient religion of the right angle.
Yeah, I come at it from a very different way. I will not deny Pythagoras' genius or his historical importance, obviously, but we have to look honestly at what the Brotherhood actually was. I know it sounds crazy to modern ears, but this was not like a primitive research university. It was a bizarre, highly dogmatic commune.
Bizarre is a good word for it.
It really was. The reality of their daily life involved mandatory simple white garments, strict vegetarianism, forcing initiates to practice absolute silence for their first 5 years, and of course, harboring a famously inexplicable phobia of fava beans.
The fava beans detail always gets me.
Right? Legend says they thought the beans contained the souls of the dead. That is not the early scientific method, okay? That is cult control. Furthermore, their belief that all is number wasn't some, elegant metaphor. They believed numbers were literal, living, physical entities.
They gave them personalities almost.
Exactly. They assigned arbitrary moral values to them, like the number 1 was the origin of all things, 2 represented matter, 3 was ideal forms, and 10 was absolute divine perfection. That isn't rationalism. That is numerology. Modern mathematics functions as an objective, universally verifiable tool that is completely divorced from that kind of dogmatic, mystical baggage. We use the math because it works, not because we think the number 10 is going to, bless our harvest.
Well, let's test that distinction, though, by looking at how they actually arrived at their beliefs. Let's look at the crown jewel of their society, the very thing that made Pythagoras a household name, which is the Pythagorean theorem. A squared plus B squared equals C squared.
A classic.
Right, everyone knows it. Now, it's true the Babylonians and Indians had practical working knowledge of right-angle relationships centuries prior. But Pythagoras, or at least his direct followers, elevated this from a handy builder's trick to a universal, immutable law through mathematical proof.
Yeah, they proved that it applies everywhere, always, without exception.
Exactly. And think about what this equation actually does on a functional level. It dictates that in any right-angle triangle, the square of the hypotenuse, so the longest side, is exactly equal to the sum of the squares of the other two sides. For them, this was a profound theological revelation. It meant that space itself is entirely predictable.
Sure, yeah.
If you know 2 dimensions of a space, you can calculate the third flawlessly without ever having to physically pull out a measuring tape. It bridged abstract human thought and physical reality. And today, that exact invisible grid is the engine running our entire digital infrastructure.
Well, you're referring to the Cartesian coordinate system here.
Yes, for those who might not remember, middle school geometry, think of the Cartesian coordinate system as a giant invisible graph paper overlaid on the world. It's an X and Y grid. When a software developer builds an app, they don't physically measure the gloss on your phone.
No, they don't.
If you swipe your finger across the screen, the software calculates the shortest distance between the starting pixel and the ending pixel by rapidly crunching Pythagoras' equation across that invisible XY grid. And it's doing this millions of times a second to render 3D environments in video games or, dictate the physics of a digital space.
I mean, that's undeniably true in a mechanical sense. The mathematics is foundational to calculating distance on a grid, but applying the equation to a pixel array doesn't mean you inherit the theology behind it. Modern coders or structural engineers using right angles to ensure cantilevered bridges and towering skyscrapers don't collapse under their own mass. They are utilizing a pragmatic tool. They aren't performing a ritual.
I see what you think that. But let me give you a different perspective. Isn't the modern programmer's absolute, unwavering trust in this invisible grid of logic functionally identical to the Pythagorean belief? I mean, the developer completely trusts the code to dictate the reality of the digital space.
Well, they trust it because they can see the output.
But the architect trusts the math to hold up the steel, often before a single beam is even forged in a factory. They believe, just as Pythagoras did, that mathematics is the underlying source code of physical reality. The absolute faith in the equation precedes the physical evidence.
I'm sorry, but I just don't buy that. Let me tell you why. Faith, in the religious or cultic sense, requires an unquestioning devotion to a dogma regardless of evidence. The modern programmer or architect trusts the equation precisely because of empirical evidence and rigorous objective proof.
But they still rely on the absolute nature of it.
Sure, but the Pythagoreans believed the numbers literally were the physical entities. A modern architect doesn't believe the right angle is a conscious living spirit holding up the bridge, They understand it's an abstract description of physical forces, gravity, and load distribution. We have abstracted the math away from the mystical entity and turned it into a pure utility. We kept the geometry and discarded the worship.
Discarded the worship, perhaps, but I don't think we discarded the search for divine beauty. Because if the universe organizes physical space perfectly, the Pythagoreans naturally wondered, well, does it organize our internal emotional experience too? And this brings us to how Pythagoras transitioned from the geometry of physical space to the geometry of sound.
Ah, yes, the blacksmith story.
Lore goes, he was walking past a blacksmith's shop and noticed that the sound of the hammers striking the anvils created pleasing, harmonious chords.
Because he realized that the harmony wasn't random. It was due to the proportional weights of the hammers.
Precisely.
And he took that physical observation and applied it to stringed instruments, which gave us the first mathematical quantification of beauty. And let's explain how this actually works, because it's just mind-blowing. If you pluck a string, it vibrates and produces a specific note.
Right.
What Pythagoras discovered is that if you pinch that string exactly in half, a perfect 2-to-1 mathematical ratio, it produces the exact same note, just 1 octave higher. A 3-to-2 ratio gives you a perfect fifth. A 4-to-3 ratio gives you a perfect fourth.
And on a biological level, what's happening is that those physical vibrations are traveling through the air and hitting our eardrums. So a 2-to-1 ratio literally means your eardrum is vibrating exactly twice as fast.
Yes, and our brains interpret that neat, tidy mathematical ratio as emotionally beautiful. This was revolutionary. For the first time in human history, something that felt entirely emotional, entirely subjective, like the human experience of music, was proven to be governed by strict, rational mathematics.
And you are totally right that this discovery remains absolutely foundational today. If you open up GarageBand or any digital audio workstation right now to synthesize electronic music, you are manipulating those exact harmonic ratios. When we compress audio files into MP3s, algorithms are discarding the frequencies outside those mathematically relevant ratios. The math holds up perfectly.
Right, our whole digital auditory world runs on it.
But you have to look at what Pythagoras did with that discovery, because that is where the cult mentality takes over. He extrapolated the string resonance to the entire cosmos. He proposed the harmony of the spheres, which was the idea that planets and stars moving in orbit do so according to these specific musical ratios.
Which is a beautiful thought.
Beautiful, yes, but he literally believed they were emitting a celestial hum that was just too vast for human ears to perceive. This is where the brilliant observation of the blacksmith's hammers takes a massive leap backward into cultic superstition. He projected a localized physical phenomenon onto the entire universe without any empirical evidence, simply because it fit his theological aesthetic. He wanted the universe to sing, so he declared that it did.
I think you are dismissing the underlying instinct as superstition, when in fact it is the exact same instinct driving modern physics.
How so?
Well, yes, the planets aren't literally humming a perfect fifth. But consider what Pythagoras was actually doing. He was trying to unify the forces of nature under a single, mathematically elegant framework. When modern theoretical physicists spend their entire careers searching for a unified theory of everything, like when they develop modern string theory proposing that fundamental particles aren't dots but vibrating one-dimensional strings, aren't they chasing the exact same celestial hum?
I mean, they're using math to find answers, sure.
But they are looking for absolute mathematical elegance in the cosmos. They assume the universe operates on beautiful, unifying math. Pythagoras was just the first author of that exact pursuit.
That's a compelling argument, but have you considered the fundamental difference in how those theories handle anomalies?
What do you mean?
A modern physicist proposes string theory as a hypothesis. If the math doesn't work out, or if the particle colliders in Geneva prove it wrong, the physicist revises the theory or discards it. For the Pythagoreans, mathematical elegance wasn't a hypothesis, it was a mandatory dogma. And nothing exposes the danger of that dogmatism quite like the crisis of irrational numbers.
Ah, yes. The great mathematical heresy. The square root of 2?
Exactly. Because the Brotherhood demanded a perfectly rational, neat universe built exclusively on whole numbers and their clean fractions. Everything had to be proportional. But their own crown jewel, the Pythagorean theorem, inherently proved the existence of something that shattered that worldview.
Right. It broke their own rules.
Completely. If you draw a simple right-angled triangle where the two shorter sides are each exactly 1 unit long, the theorem dictates that the square of the hypotenuse is 1 squared plus 1 squared, which equals 2. Therefore, the length of the hypotenuse is the square root of 2.
Which seems innocent enough to anyone who has used a calculator.
Sure, today it does. But mathematically, the square root of 2 is an irrational number. It cannot be expressed as a simple fraction of 2 whole numbers. The decimals go on forever without ever repeating or resolving, 1.4142135 on into infinity. To understand why this was terrifying to them, imagine trying to measure the diagonal of a perfectly square room,
but every time you zoom in with your ruler, the marks never line up perfectly with the corner.
Right.
You zoom in 1,000 times, 1,000,000 times, and it never resolves. It just keeps going. It is messy, it is infinite. And to the Pythagoreans, it was a horrifying anomaly. It meant that the very fabric of space contained distances that were fundamentally incommensurable. It broke their perfect, neat universe.
And it is well documented that they did not handle that revelation well.
To put it mildly, when a member of the Brotherhood, Hippasus, revealed the existence of irrational numbers to the outside world, the cult viewed it as an unforgivable heresy. Legend states they took him out to sea and threw him overboard. They murdered him.
Yeah, it's the dark piece of mathematical history.
But this perfectly illustrates my point. They were violent zealots willing to kill to protect the perfect geometry of their dogma. Modern mathematical rationalism only truly began when we broke from this cultic behavior and accepted irrational numbers. We embraced the messy, infinite reality of the math rather than murdering the messenger. That acceptance is the dividing line between mysticism and true rationalism.
That's an interesting point, though I would frame it differently. I don't think the murder of Hippasus represents a break from modern rationalism. I think it proves just how deeply mathematics was ingrained as their theology. It was a profound crisis of faith. You say the messy reality of irrational numbers breaks the Pythagorean dream, but I argue that modern technology proves they were ultimately right all along about the universe's predictable numerical structure. Let's look at the GPS in your phone.
A system that relies entirely on navigating those messy, complex calculations.
Absolutely, it relies on complex triangulation. When you navigate a city, the satellites orbiting the Earth are essentially playing a massive geometry game. A satellite pings your phone to measure the time a signal takes to travel. Because the speed of light is constant, it knows exactly how far away you are, creating this giant virtual sphere of probability.
Right, and then you need more satellites.
Exactly. When a second and third satellite do the same thing, those spheres intersect. That intersection pinpoints your exact location in 3D space. That complex triangulation is, at its absolute core, the Pythagorean theorem scaled up to a planetary level.
I agree that the geometry scales up.
Right. So yes, we had to figure out how to handle the infinite decimals of irrational numbers. And yes, we had to factor in Einstein's relativistic physics because gravity affects time. But the fundamental premise remains totally intact. The invisible grid is real. Space is predictable through geometry. We figured out how to navigate the messy details of irrationality, but the overarching Pythagorean thesis that the cosmos can be decoded through numerical relationships is exactly what puts the blue dot on your screen.
But let's talk about how we handle those messy details, because that's where the mysticism dies. We don't worship the infinite string of decimals in an irrational number. We truncate them. Our algorithms literally chop off the infinity at the 15th or 30th decimal place just to make it fit inside our computer memory.
Well, we have to for it to work.
Exactly. It puts the blue dot on the screen because the equation accurately models spatial dimensions, not because the universe possesses a divine inherent morality of numbers. By pointing to GPS and truncation, you are actually highlighting the triumphs of the tool over the theology. We took the geometry that Hippasus died for, stripped it of its infinite divine perfection, forced it into a digital box, and used it to find the nearest coffee shop.
Right, we made it mundane.
We did. The Pythagoreans would likely be horrified by how mundanely we treat their sacred numbers. We have commodified their gods. That is why modern engineers are not mystics, they are utilitarians.
I hear you, but doesn't the sheer utility of it inspire a kind of awe that borders on the mystical? I mean, we may have commodified the numbers, we may chop off the decimals, but when a theoretical physicist looks at an equation that perfectly predicts the existence of a black hole decades before a telescope ever captures it, the language they use to describe that equation is incredibly revealing.
They do talk about beauty, I'll give you that.
They don't just talk about utility, they talk about elegance, they talk about beauty. The physicist Eugene Wigner famously wrote a paper on the unreasonable effectiveness of mathematics in the natural sciences. That feeling, that profound, almost chilling shock that the physical universe actually obeys the scribbles on our chalkboards, is exactly what Pythagoras felt in that blacksmith shop.
Awe and mysticism are not the same thing, though. Awe is an emotional response to discovering how the universe mechanically works. Mysticism is the assumption that the universe works that way because it is imbued with a conscious, divine spirit. The Pythagoreans could not separate the two. They believed the numbers themselves were the divine spirits.
But don't you think their reverence is similar?
Not really. When a modern developer uses a mathematical library to render a digital environment, they may feel profound awe at the elegance and efficiency of the code. But they do not believe the code possesses a literal soul. They don't practice 5 years of silence to appease the algorithm. And, they don't ban fava beans from the server room. The rituals of the cult are gone, and what remains is the pure, unadulterated mechanics of logic.
Well, I think we're reaching the point where we need to synthesize these perspectives, because we are looking at two sides of a remarkably enduring coin. To summarize my position, while we certainly no longer sacrifice oxen when we solve a difficult equation, and we don't wear white robes in the server room, the foundational premise established in Croton 2,500 years ago holds entirely true.
The invisible grid.
Yes, beneath the messy, chaotic surface of nature lies an invisible grid of absolute logic. We trust it implicitly to hold up our bridges, synthesize our music, and guide our satellites. In that profound trust, in our unwavering belief that the universe's source code is mathematically elegant, we are essentially still practicing the ancient religion of the right angle.
And to summarize my stance, the legacy of Pythagoras is undeniably a fascinating paradox. But we must separate the man's mathematical contributions from his cult's dogmatic failures. Modern mathematical rationalism is defined exactly by its rigorous proofs, its willingness to revise theories based on evidence, and its ultimate acceptance of messy anomalies like irrational numbers.
Right, we don't throw people overboard anymore.
We don't murder people over infinite decimals anymore. We write algorithms to navigate them. That acceptance represents a distinct and necessary liberation from the superstitious, violent dogma of the ancient brotherhood. We are users of a brilliant tool, not disciples of a mystic.
It is a tension that I suspect will endure as long as we continue to push the boundaries of physics, architecture, and code. The source material we drew from today offers even more incredible depth on how these ancient equations shaped the entire history of modern engineering, and it is absolutely well worth exploring further. So, the next time you look at a towering skyscraper or unlock the smartphone in your hand, you have to ask yourself, are you merely a user of highly advanced, pragmatic technology? Or are you holding a tiny temple, an unwitting disciple of the divine geometry? We leave that for you to decide.
Ancient people were master engineers. Subscribe to Ancient Archive Blueprints as we explore more master designs from the past.